So here's the continuation of the geometric series, and there's some other stuff in here that probably should have been talked about, but when I made the notes, I just wasn't thinking about it. So the U-try from yesterday, it was this pattern, 16:4:1. The ratio, and I'm not plugged in, that's this. The ratio here is 4/16 or 1/4, and they're equivalent, right? So let's take a look at the graph. Remember, I've said that you don't really understand math until you understand graphs, because graphs tell you lots of things. Like, of course, I've been doing this a long time. I know that this is something we call exponential decay. I also know that because it's an exponential function, it has what we call a horizontal asymptote. We're going to see this thing flatline at some point in time. See how it flatlined? What's happening is as you move to the right, and we can look at the table here, as you move to the right, this value of y is getting closer and closer to zero. Now, I understand that's in scientific notation, but like this number right here has 6 zeros in front of that too, right? And you get down here where x is, let's just go to 30. You have 16 zeros in front of that 6. What's happening is the y values, or the output, or the term, the nth term, I don't know why I wrote it like that, but the nth term approaches 0. And at infinity, it is essentially 0. At infinity, if you could ever touch infinity, its value would be 0. So we are dealing with what's called the sum of an infinite series. An infinite series has an R ratio that is less than 1. Because if the absolute value of the ratio is less than 1, the series converges on 0. It approaches an output of 0. And it has the easiest formula. The sum of an infinite series is simply the first term divided by 1 minus r. It's kind of cool that you can find the sum of something that goes on forever, but you can't. All right, decide if the series shown converges at infinity or not. Find the sum as n approaches infinity. Now this one looks like mx plus b, so it's like not even geometric. Like it's arithmetic. There is no r. All right, so on this one, I can look at this one and I can tell you that the ratio is 3. Not everybody can. So if I plug in a 1, I'll get a 6. If I plug in a 2, I'll get an 18. If I plug in a 3, I would get an 81. No, that's not right. It's 27, 38. Yeah, I'd get an 81. That's supposed to be... Boy, I have messed up here, haven't I? 618. I should be getting something else. Like I had a brain fart or something here. 3 cubed is 27, right? Twice 27, 54. I did have a huge brain fart. I had 81 stuck in my head. So the ratio here is 18/6, which is 3. 54/18. The ratio is 3. 3 is bigger than 1. This does not converge. So all you're supposed to do is, if so, find the sum as n approaches infinity. So this one, this is my ratio. It's a third. All right. I need to know the first term. It's 4 times a third to the first. And if I go push buttons or whatever I do, I'm going to get 4/3. First term's not 4 on this one. It's worked a little bit different. So the sum of the infinite series, again, is the first term over 1 minus the ratio. So it's 4/3 over 1 minus third. Now, I like to do these things old school. That's 4/3 over 2/3. Threes cancel. 4 over 2 is 2. Now, if you don't believe me, you know, God bless y'all. Your first instinct is to go straight to a calculator instead of use that brain your good Lord gave you. So math num n over d, that's why some of y'all don't know things. You know, not everybody is capable of doing things, but most of us are. And we just choose this path of ignorance. It just absolutely sickens me how dependent we decide to become upon things. But there you go. If you're that kid who's dependent on a calculator, it's 2. All right. All right, choice 4. A sub n is 3 times a sixth to the n minus 1. Now this one is in the correct form. This is a sub 1 times r to the n minus 1. So I know that the first term is 3. And I know the ratio is a sixth. And I know that 1/6 is less than 1. So this definitely converges on 0. So if it converges on 0, I can find the sum of the infinite sequence by doing the first term over 1 minus a sixth. That would be 3 over 5/6. All right? That would be 3 times 6 over 5. That would be 18/5. Again, you know, whatever. Let's go be dependent on a calculator. 3 divided by parentheses 1 minus a sixth. Notice the use of parentheses when you're writing sideways like this, you got to use parentheses. But Milbrath, that's 3.6. That's not what you wrote. Math, enter. Doofus. Same thing, 18/5. One of them's bigger than the other, and that's 18/5. All right, so this one, there's your ratio. It's 2. 2 is bigger than 1. The goal is to be less than 1. Does not converge. And the last one, does this one converge? Probably, but it's not in the right form. So you're going to have to do some work to get the first term. The first term is 3 times a half to the first, which is 3/2. Be very cautious about picking out the first term. If the form is a sub 1 times r to the n minus 1, just trust what's given, all right? Now this is your ratio because the bases are the ratio. So the ratio is a half. And I know that a half is less than 1, so I know the series converges on 0. So I'm going to use my little sum of infinity formula. First term over 1 minus r. The first term was 3/2. It's going to be over 1 minus a half. That's 3/2 over a half. 2's cancel. It's 3. And I ain't going to push buttons to prove to you it's right. Go push your own blasted buttons if you got to do it. All right, some stuff that I should have talked about previous days. This one has been talked about. It's worth doing again because I know it's going to be a rough one for y'all. A geometric sequence has a first term of 3, common ratio of 2. How many terms does it take to reach a sum of 3069? So for geometric, the sum of n things is the first term times 1 minus r to the n over 1 minus r. All right, I know the sum is 3069. It must be equal to the first term of 3 times 1 minus 2 to the n. If it's positive, don't worry about wrapping over 1 minus 2. It's 3069 equals 3 times 1 minus 2 to the n over a negative 1. That's going to make that a negative 3, right? We're going to divide that negative 3 out. That's going to be 1,023, negative 1,023, equals 1 minus 2 to the n. I'm going to subtract the 1. Negative 1,024 equals negative 2 to the n. I'm going to divide out the negativity. And I'm going to have, not negative 2, just negative 1. I almost made a huge mistake there. You cannot divide the base out. 1,024 is 2 to the n. And if you don't know what a power of 1,024 is, you know, you're not expected to. You can just do logarithms, right? You can do a log base 2 of 1,024 is n. And then you can go to your trusty TI-84 and you can do change of base. I like ln of 1,024, sitting pretty. over the ln of 2 should be a nice whole number. And it is, it's 10. So n is 10. Give me a minute. All right, 2 to go. Express the series 3 plus 12 plus ... 3072 using sigma notation. All right. And the question mark is, where does it stop? The series is easy. The ratio is 4. The first term is 3. So the sequence itself is 3 times 4 to the n minus 1. The question is, where does it stop? But since I was able to write this, I know that 3 times 4 to the n minus 1 must equal 3072. Isolate the base, divide both sides by 3. That'll give you 1024 is equal to n minus 1. Sorry, is equal to 4 to the n minus 1. Now, I happen to know that 4 to the 5th is 1024, but you might not. So I'm going to do a log whose base is 4, its argument is 1024, and it equals n minus 1. Change your base, natural log, again of 1024, but this time it's divided by the natural log of 4. And I'm going to get a 5. Like I told you earlier, 5 is n minus 1, n is 6. So there's the full guy, 6. And last one, you are given 2 terms of geometric sequence. The 5th term is 10, the 12th term is 5/64. Find the first term, the common ratio, and write both the recursive and explicit rules for the sequence. Okie dokie. So I talk about a sub 5. It is 10. It must equal the first term times the ratio to the, it is a sub 5, 5 minus 1. I talk about a sub 12. It must equal the first term times the ratio to the 12 minus 1, and a sub 12 is 5/64, so it must equal the first term times the ratio to the 11th. And that guy right there will change to the 4th. As I explained yesterday, always solve the small equation for a sub 1. So 10 over r to the 4th is a sub 1. Plug it back in. 5/64 equals 10 over r to the 4th times r to the 11th. R to the 11th over r to the 4th is r to the 7th. So 5/64 equals 10 r to the 7th. Divide both sides by 10. 5 over 640 equals r to the 7th. And let's go see what the ratio is. Well, 5 over 640, by the way, does reduce. It's 1 over 128. But, you know, whatever. You don't have to do all that. The opposite of the 7th power is the 1/7 power. So take 5 over 640. You didn't realize it reduced. Raise it to the 1/7 power, and you'll have your ratio. And it should be a half. And it is. Don't ask me how I know that. I just know these things. So r is a half. Plug it in. 10 over 1/2 to the 4th power is the first term. All right, a half to the 4th power should be a 16th. 10 over 1/16 is the first term. And that means the first term is going to have to be 160. So my explicit rule is I am the first term of 160 times the common ratio of a half raised to the n minus 1. My recursive rule, I got a minute before the bell for first period, is I am the first term of 160 if n is 1. Otherwise, I am 1/2 of the previous term if n is greater than 1. There you go. Easy peasy, lemon squeezy, all that good stuff. Hope you enjoyed. We both know you didn't.